my screen and let's start. We are going to talk to you and present you today, after a short introduction, the international standards and minimum energy performance standards concerning motor systems. First, a little bit about standards and regulations in general, then the overview of the MEPS, and then specifically we will go through the MEPS for motors, variable speed drives, fans, pumps, and compressors. Then we would like to show some recent developments, which we hope that will also feed into the discussion at the end of the webinar. Aspects like circularity or a more widespread use of variable speed drives. We will also address the question of where is the system boundary, and we would like to touch on supporting policies to MEPS, minimum energy performance standards. Last but not least, we would like to mention some sources. Didert already pointed to one that we will specifically mention today. For those who are not familiar with the IEA TCP4E Electric Motor Systems platform, this is a collaboration under a technology collaboration program of the International Energy Agency called 4E, the Energy Efficient End Use Equipment. It includes 15 member countries, and EMSA, the platform dedicated to electric motor systems, has 9 members. EMSA is working on raising awareness, sharing information, and initiating collaborative projects to transfer experience and support effective policy development for energy-efficient electric motor systems. Some of the topics that we are working on include international standards, testing, coordination and alignment, digitalization, demand flexibility. We also have a dedicated tool, the motor systems tool, and an expert pool who can help you with the use of the motor systems tool. The 9 members I would like to mention explicitly. These are Australia, Austria, Denmark, the European Commission, the Netherlands, New Zealand, Sweden, Switzerland, and the US. EMSA liaises with a number of different stakeholders, which you can see on the figure on the left side. I'm not going to go into details on this one. EMSA also works on different levels of impact, meaning individual awareness. So with our newsletters, with our information materials, we target individuals, professionals working in this field. And also we target the company policies, a company level. Above that are the national policies. The primary goal is, of course, to help policymakers design and implement effective policies. And the further layer are the international standards. EMSA is actively involved through some of its members as national experts in different international standardization committees and groups. Here is a detailed slide. I don't want to go into the very details, but just to show you that EMSA is currently running its project cycle of 5 years from 2024 to 2029. And there are different topics that EMSA is working on, like standardization, policy design and tools, for example, addressing embedded motors, or policies for speeding up market transformation. Here we also have a link to the EU MORE project, some of you may be familiar with. We address the future of efficient motor systems, and as I mentioned before, we offer some tools for users and other professionals. Then another subject is technology monitoring, like digitalization of motor systems or demand flexibility in industrial motor systems, as well as silicon carbide converters with industrial motors. Last but not least, we have the Knowledge Hub, which is, on the one hand, the dissemination of our work results, and on the other hand, we are also keen on having continued dialogue with industry, meaning industrial associations, and this we call the Industrial Bridge. Within 4E, there are also other platforms. Some of them we collaborate with on selected topics, like the Power Electronic Conversion Technology platform or the Efficient Demand Flexible Networked Appliances platform. This is just a reminder. I think everybody is familiar with this, what we mean with electric motor systems and what EMSA's primary target is, which is the system in its entire complexity, meaning the variable frequency drive, the motor, the mechanical equipment, if there is one, and the driven application. And the average savings potential on the system level are between 20 to 30%, so we work on the system level. Now I give the floor to Maarten.
Thank you, Rita. I take over from you. I will start with, and then I first have to share the same presentation then from my side. Yes, there we are. So I will start with some more in-depth information about international standards and MEPS. First, the same figure as Rita showed. And the idea is that I show you the technical background of the different components. Being at the left, IEC covered standards, electrotechnical standards, and at the right, the mechanical part covered by ISO standards, both of them through the different individual TCs, technical committees. As you can see below in blue, the TCs for the electrotechnical components, the control and the motor, and to the right in red, the mechanical components by the different TCs, of which each TC is responsible for developing and publishing the standards for the related energy efficiency subjects. So that's the starting point. And last but not least, I also like to mention JAG22, which is a combined, a joint advisory group, joint standing for Joint ISO-IEC, working on the subject of optimized energy and power consumption of electric-driven machine units. What JAG22 does is not making new standards, no, it gives a platform for coordination and alignment activities, which then can be taken up by the individual TCs. Having said that, what is the importance of standards and how do they look like? You see here a table with the 5 main components of a motor system. And for each of them, it's important to define the actual scope, which kind of products are in scope of a standard, the different types of products, and then as a second, the testing standards. How can you test, how do you need to test that specific product? And then testing in terms of the actual energy use and efficiency. And thirdly, then the efficiency classification standards, meaning assigning an actual efficiency to a certain product. The 3 of them form the basis for any regulation by government. So without those standards, it's impossible for any government to make a proper regulation defining the minimum efficiencies for a certain product. And it goes for any of the products listed, so the motor, the converter, pump, fan, compressor by themselves. This is the same scheme or the table, but then with the appropriate information concerning the products. And it shows a number of things where, first of all, you can see the scope I've now just highlighted or just filled in for the name of the group of products covered for these specific listed standards. For the motor, these are 3-phase induction motors, and they can see for this line that the testing standards are listed, also the classification standards, and the actual metric which is defined in the standard. So the motors, you now see a number of countries do have MEPS in place. It's all on the product level. The same goes for the converter, where we see the VSD, the converter, the listed standards. As such, there's only one country or region, EU, which has a MEPS in place for VSDs. Then when we make the step to the pump and the fan and the air compressor, what you can see, if you take a look at the testing standard column, you see all standards are either IEC or ISO, electrotechnical or mechanical. That's not the case for the efficiency classification standard, where you see that for the motor and converter, these are IEC standards only. But when we move to the pumps, you see that we list EU or EN standards for Europe, US standard, and a Chinese standard. So for pumps, the standards are not, so to say, brought to the ISO level, but are shaped to the regional market. Also, what you can see there for the pumps, we see an MEI, minimum efficiency index for pumps, covering the product only, and then the EEI and the PEI for EU and US, meaning that these metrics cover the units, so the unit of being a motor, converter, and pump together. So that's these regulations in place in the EU and the US do cover the complete unit. For the fans, we see something different, where we see that the fans do have the actual efficiency classification standard on ISO level for the different metrics. So each metric, let's put differently, different countries like China use different metrics. China has the FEG, which is the metric on primarily the fan only, where we see the EU has metrics on the unit, the fan, the motor, and the converter. And the US now has a regulation in development, but already the test method is there, which covers also the unit. It's a different metric, the FEI. And last but not least, the air compressors, we see an ISO standard, testing standard, and we see two classification standards for the Chinese market from China and from US. Both are covered in the regulation. Okay, so much for this section. So you see that the standards which are listed here, shown here, are so the basis for the actual regulations in place in the different countries. Okay. Next, I start with motors, where I think many of you have seen this slide before, but just I show it once again, the different, and I show it before, just again to show you the different labels, the classes, I must say, different efficiency classes for a motor, I1 being the lowest, I5 the highest. I5 is covered in this standard, the 600-34-30-2, meaning that's a standard with efficiency classification for VSD driven motors. And from I1 to I5, it's an increasing level of efficiency, where the differences for small motors is quite big, and the differences between the classes for bigger motors, larger motors, is quite small. Having said that, I show you the slide with an overview of the current status of MEPS for motors on the globe. And it shows the IE classes for the different countries in different colors. The lowest class, I1 in red, you see a few countries still have IE1, but they still have a MEPS, that's good. Then we see the IE2 in orange. You see, for instance, Australia, India, other countries, also in Africa, Ghana, but also countries which do already have regulation in place to go to I2 soon. Then we see the I3. I3 is covered in 4 of the 5 different continents. And we see also a dark blue for those, for that country, I must say, that's being the US, which already has decided to go to I4. And that's the case as well for Europe, where I4 is already in place and in working, meaning the EU countries have to comply to the I4 level already. We're working, well, first I'd like to say that this map of maps is now available on our website. It's ready for download, including the table with the information behind this, map. And we're working on a comparable figure for the pumps, the fans, and the compressor maps. So I'd like to quickly make a short step backwards, 8 years back, looking at the market at that time. How did it look back then, 8 years ago, when we talk about maps for motors? And this is how it shows. You see the different countries at I3, at I2 as well, some at I1. The range you see also from 0.75 to max 375. In total, you see 17 countries 8 years ago, which had maps for motors in place. None of them had maps for I4. And we see, to be honest, at the moment, 12 countries having maps in place for at I3. So that brings me to a little poll. And then I switch to Rita, who will take us over from here. Rita.
Okay, I just launched the poll. So inviting you all to indeed select, what do you think? How many countries currently have maps for motors at I3 level? And I see most of you already found the way to the voting button. So we'll give it another, let's say 30 seconds. Two out of 3 have voted, so 15 final seconds. Please send in your votes now. I still see votes coming in, so wait a few. Okay. There we are with the results, and I give you the floor again to comment on that, Maarten.
Great. Well, thank you, Rita, and thank you all for filling in the vote, filling in your vote. The answer is 20, and I show you right away. I close this one, so the majority did make a good vote, or guess, I must say. This is how it looks like. This is the current status of maps for motors. The question was, how many countries do have maps in place at I3 level? And the answer is, I must take a good look, 20. So 20 have maps in place at I3. And I had to take a good look because I had written down the total number of countries which do have maps in place, with either being I1, 2, 3, or 4, and that number is 29. And as you recall, the total number of countries having maps in place 8 years ago was 17, so it's a plus of 70%. So a huge increase of countries having implemented maps for motors. The countries which do have MEPS in place at IE3 level in total cover approximately 80% of the global electricity use for motors. So that's the biggest chunk of electricity used by motors worldwide at this moment. Because you have to bear in mind that the total electricity use of motors increases the coming 10, 20 years considerably. So that percentage may drop when we take a next look in the next decade. I go to the next slide, and that shows a bit more in detail the different MEPS. First, the MEPS for motors at EU level. What you see here is, in a nutshell, the different motors covered in the EU. In the middle, you see the section with the green, orange, and blue. That relates to three-phase induction motors, 2 to 8 poles together, continuous duty. Interesting to note is that also motors for explosive atmospheres are covered. And also, of course, the I4, which is new in the world. Those cover 2 to 4 and 6 pole motors between 75 and 200 kilowatts. It also includes information requirements for motors at part load and partial speed, motors and VSDs. And that's also an important addition compared to the old MEPS. Then also covered are the one-phase motors at the IE2 level, and also the motors for explosive atmospheres. So it's the most stringent class for explosive atmospheres. Those also have IE2. And also important to note, it covers the full range of the standard being 0.12 up to 1000 kilowatts. Then we have for the VSDs also MEPS, which is also the first in the world. And we cover the full power range, three-phase variable speed drives. And these are so-called standard VSDs. Then when we make a step to the US, there I've shown the current MEPS at the left, where you see that the covered power range is smaller, at 0.75 up to 375 kilowatts at the I3 level, and then depending on the number of poles, a bit smaller, even up to 8 poles. So those are the current covered motors in the current MEPS, I must say. Some exclusions. And also the next step, and that's important, so that's why I already listed them here at the right. You see the new MEPS, which have already been adopted in 2023 by direct final rule, and the compliance starts in 3 years from now, less than 3 years. And they say they've pretty much aligned to the new EU MEPS. So they have also I4 at between 75 and 200 kilowatts. Here also the 8-pole motors are included. And excuse me. And also then we see that a few other motors are specific motors types are defined in these MEPS. Relevant here, I will very shortly, the dedicated purpose pool pump motors are also new to be covered in 2027, 2029, a specific category, and also the small motors at the left, bottom left, small motors, specific requirements for these type of motors. Then the third big region is China. For China, we have MEPS in place at the left, the three-phase induction motors, 2 to 8 poles, and also some exclusions. This is as per 21st June 2021. And also for the smaller motors, big sections, single-phase motors between 0.12 and 3.7 kilowatts with different specifications. and also a bit different classifications compared to the IC standard. Important also to note that in China, permanent magnet synchronous motors are also regulated, and you see the specifics listed here. The line start 3-phase PM motors, but also the VFD-driven PM motors, the different grades and different power range. Yeah, okay. So that's and almost, but not all, aligned to the IC standard. So having shown these maps, what does it mean? Do we know something about the effect of those maps? Well, we do. We can show you this slide with the market change as noted by MEPS, the Association of Motor Manufacturers in Europe, covering the biggest portion of the market. And what you see here is the actual sales of motors by efficiency classes, with IE1 in blue and in the end the IE4 in yellow. And you see exactly at what point MEPS have been introduced. The first years before 2010, we had a voluntary MEPS in place for an F1, F2 classification, low profile, or not that low profile, but not that effective. The main motors, as you can see, were still IE1. If slowly IE2 came to the market. Then in 2011, the first stage MEPS, mandatory MEPS at IE2. Stage 2, mandatory MEPS at IE3, and also the combination IE2 plus VSD. You see that a sharp increase of the percentage or the share of IE2 motors as a result of those MEPS. And then coming to the stage 3, and I must say, in fact, stage 4, where the IE3 has become mandatory 2021. You see a strong, steady increase of IE3. And now, when we are in 2022, you see that the big majority of motors sold are at IE3 and small section IE4. So it's proof that MEPS do work, for one. And another one is a slide on the actual savings. Again, I take EU as an example, as we do have this data available. What you see here are savings by motor MEPS. It's based on the eco-design impact accounting of 2023. You see the total savings of, I must say, first, the total electricity used by motors, by electric motors, sorry for this. So the upper line is the electricity used by motors with the business as usual, just without MEPS. Then you see the savings as reported by the MEPS for pumps, in yellow by fans, and in orange by motors. The total savings, and then I must also say that we're talking about impact accounting. So up till 2020, it's an accounting issue, a result of the reported sales and efficiency classes. Looking forward, it's a projection of how the market will develop. In 2020, the total savings add up to almost 8%, and then ongoing up to 2040, it touches the 12% savings on the electricity use of motor systems. This slide I added just to note for some awareness that in the EU we do have 30 products covered by MEPS, and I only showed you 3, being motors, pumps, and fans. But motors are also present in a number of other products which are covered by MEPS. So in the accounting, they are allocated to those MEPS, but it's just to show you that these occur by the sake having efficient motors. So I showed you this extra layer shown here, which stands for the savings by other products, which, for instance, are the non-residential ventilation units and refrigeration units, air cooling and heating equipment, and space and water heating. So that you don't forget that, in fact, the effect of efficient motors in the market is even bigger than just looking at the numbers for the motors, fans, and pumps. That's the case in the EU. So for those countries who want to start with MEPS for motors, it's interesting to bear in the back of your head. Okay. Next, I make the step to fans, industrial fans, MEPS in place in the EU and China. To the far left, China, MEPS updated in 2020. It covers the fan only to a large extent. The different types of fans are listed, primarily or only centrifugal fans and axial fans, different types. The metric used is the FEG, so it's the fan efficiency grade. But I must say in 2020, a small addition has been made, at least for the forward curved fans, where also the motor and the VSD are included. So a step has been made to move from the fan only to also including the motor and the VSD. 3 efficiency grades are defined in China. In the EU, the revised MEPS just has been published in July this year. You see here also axial centrifugal fans, the biggest chunk of the fans, at least in industry. But we also see cross-flow fans included, mixed flow fans, and also jet fans. So these are not included in the Chinese MEPS. Power range from small, 125 watts to 500 kilowatts, they're very big fans. Here, the metric is the FMEG, and the efficiency grade is expressed in N value, at the best efficiency point. The same is the case in China. In the MEPS is also included information requirements for partial load, and 3 performance curves have to be specified by the manufacturer. When you now look at the US, the test method has been adopted, so it's a rule, but not yet a MEPS has been adopted. You can see here that in the test method, the different fan types have been defined. Also, axial and centrifugal fans. Not included are the cross-flow fans, the mixed flow, and the jet fans. Most relevant here to mention is the other metric, the FEI, Fan Efficiency Index, where EU and China have a metric which relates to the best efficiency point. In the US, the FEI is totally different, and it specifies the fan index, efficiency index, at every duty point as specified by the manufacturer, meaning that the manufacturer have to show the performance curve for the different FEIs for each fan. So for any end user, it's pretty much clear at which duty point which FEI is applicable. Okay, that about fans. Then pumps, clean water pumps, MEPS in place in the 3 big regions. We see, as you can see, the different types of pumps specified. I won't go into that. What I wanted to show here especially is that in the US, the full unit is covered, being pump, the motor, and VSD. And the regulation covers both, 3 different configurations, the bare pump only, pump with a motor, a pump with a motor and VSD. PEI is specified or applicable. And for the EU, currently the current regulation, which is under revision, but covers only the pump itself, so the hydraulic part of the pump. And again, here it's a different metric, so related to the best efficiency point. Interesting to know, to note is that the regulation is under the revision for quite a long time, I must say. But it looks now that within a year, the planning is that within a year, the new revised regulation will be published. We do have a draft document, but it's still a draft. And there it shows that the route is chosen, or is at least in the picture, to include the water pump unit. So again, the unit being the pump, the motor, and the VSD, in such a way that for these typical applications, only VSD-driven units comply. That's one. And the second one is that also booster sets will be included. And then in China, as mentioned, the efficiency index for pump is also addressing the hydraulic efficiency only. Showing here the effect of including the pump unit in your regulation. It shows in this case calculation based on the impact accounting again. And the orange line shows you the extra savings compared to business as usual, blue, and in green, the current savings with the current MEPS. You see that's a huge difference. So it's very relevant to really make the revision work soon. Air compressors. Here we see two countries have MEPS in place, being the US and China. And interesting to note here is that both countries cover the complete package, compressor, motor, and VSD, where in the US, it's air-cooled, liquid-cooled, fixed variable speed. They use the package isentropic efficiency with the D factor being able then to differentiate between the total efficiency and compared to China, where they apply the specific input power. And you can easily recalculate from specific input power to isentropic efficiency, but in terms of enforcement, it's much easier, and also for end users having to specify the efficiency only instead of specific input power for each type of compressor package. And in the EU, there's no regulation yet, and there are no plans on short term to make those regulations. Then I move to monitoring, verification, and enforcement. I put in this slide just to show you and to, again, also tell you that MEPS with standards are one, but we do need a good system of MV&E in order to make MEPS work. MV&E scheme is made fit for each national legal framework. There are some big differences between regions, countries, compared with the US, EU, China, but also other regions, other countries. And it involves all stakeholders, as you see in this nice figure. I borrowed from CLASP. It shows at the top left manufacturers who have to go through conformity assessment, have to verify that their product really complies. And then the regulator has to assess that in order to be able to grant access to that product grant access to their markets. Then market surveillance, where the regulator has to monitor and verify if products brought to the market really do comply. And enforcement, to assess and also to, if products don't comply, enforce that. So there have to be fines and proportionate actions to expel those products from the market. So that's a whole system of MV&E, and that's essential to get to good MEPS. And also it means that there are burden for every stakeholder involved in terms of work for manufacturers to test, work for regulators, work for MSAs, etc. It's important to bear in the back of our minds. Good. Then chapter 2, MEPS developments. A few items I'd like to mention. Circularity, aspect of circularity. It stands for moving from a consumption and disposal based model to a more circular flow and reuse of resources. At least that's how it's applied in the EU. And there's been a new eco-design framework adopted, which really bears a lot of this circularity in it. And the reason I show it is that besides energy efficiency alone, only, it also covers subjects as resource efficiency, so the material used, but also aspects as durability of the product, reusability, repairability, recycling, etc., etc. The use of carbon, environmental footprints, and information requirements. That's all sort of the framework now has been set, and it's now ready to be implemented through the different specific regulations. The new MEPS for motors, which the revision will start soon, will then be under this new ESPR framework. Variable speed drives capturing the savings from controls. I mentioned two sources. One is research done by the Fraunhofer Institute, reported at EMOTS in Lucerne this year. It shows a 10% extra savings on the energy use of motors by bringing VSDs to the market. You see a very short figure with fans, PEPs, compressors. So it's a market research identifying, calculating the actual potential savings by VSDs. It also specifies 3 potential policy approaches to actually do this, to make it work. First is one, making VSDs mandatory with all newly sold motors. You can of course think of making VSDs mandatory, not for motors, but for instance for pumps, specific applications. But of course doing so, meaning that you add cost to every product. You have not to buy a motor alone, but also a VSD. It has benefits for most of the end users because you have extra savings, but not for all maybe. And there are of course regulatory issues, how to enforce, how to make it work. So there are many implications by such a policy approach, but still it looks maybe promising. The second one is recommendation is system must reach a minimum efficiency in different load points. So based on, for instance, an energy efficiency index. And there I refer to the second source being the NEMA power index, which could be just that. The power index is a means to compare the savings of a motor, that could be fixed or variable speed, to a standard baseline motor. The essence is that the power index uses a series of load points, and then you can easily see if the actual applied motor or motor VSD is more efficient than the standard baseline. So that's one. Another one. Then the third policy recommendation is information requirements. So the OEM has to declare the actual energy cost of an assembled system. That's also an option, meaning that the OEM, of course, does have to do a lot of work, or at least some extra work, to actually calculate those energy costs. Okay. Then I move to my last slide, being going from product to systems. And It refers to a research done by the IA4E, and it's from 2022. And what it does, it did some research into how many energy potential savings are there when you extend your system boundary from the product alone to a system. And for instance, you see here listed in the figure, compressed air system, pump systems, fan systems, but also steam systems. So you see that the total savings by extending the product policies to system policies is huge. But at the left, and that's the main part, of course, if regulators want to regulate the efficiency of a system, they do have some needs. They need the scope to identify those systems, which are in, which are out. The addressees of the regulation, who it concerns, the metrics and the requirements for that system, and also the performance assessment. How can you test that's the actual performance? So that's also something for the market, for the standard makers to come with solutions. Okay, here I hand over to Rita.
Thank you, Maarten. I will share in a moment. Today we are talking about MEPS, which really set the base for advancing efficiency of motor systems. However, a policy toolkit should also comprise other measures like awareness raising, capacity building, and financial support. These supporting policies are essential. Why? Because of the motor stock. MEPS regulate newly sold equipment. However, it takes time, long time, that this shift in the sales of motors is actually being reflected in the installed base in the motor stock. This figure nicely shows that even in 2022, the share of IE1 and IE2 within the motor stock was significant. When we talk about awareness raising and capacity building, we are thinking about different stakeholder groups, which are all affected by, or should be affected by, awareness raising and capacity building. To raise awareness among end users is important so that they are aware of their energy consumption. Digitalization is a helpful tool for this. You can check out the link below. EMSA did a number of publications on the subject of digitalization. End users should be aware of their saving potentials, life cycle costs, and multiple benefits of optimizing motor systems, meaning not only energy savings, but other benefits. We have learned from the EU MORE project, which has done a comprehensive review of policy measures in Europe targeting motor replacement, that energy audits often fail to identify motor systems. And hence, this is just another message for the need of qualified and certified auditors who can spot potentials and accompany measures. Governmental agencies are crucial, so they have enough capacities for enforcement. Otherwise, all the savings that are projected with the implementation of MEPS cannot be reaped to their full potential. Utilities also have an important role. So they can include motor systems in their energy saving programs. And of course, manufacturers and OEMs of motor systems need to be successful in educating their clients and selling more efficient solutions. Financial support. The goal should be to target system optimization. So not only one component, not only the low-hanging fruits, and it should focus on the largest potential, being typically old, big, oversized machines. Even financial support programs need to be accompanied by dedicated training, tools, and information to reach their target audience. I tried to capture this with this figure, which is a bit like a darts figure, the most important point in the middle. However, all the others are also needed. Some key factors for a successful subsidy program include how to reach the target group. And of course, the target group should be aware of the financial incentive that is available for them. An easy participation in the program, a tangible subsidy, and the qualification of involved consultants, meaning very often companies need external help to optimize their systems, and for this, qualified help is needed. The last webinar in this Motors Academy was dedicated specifically to this subject. So if you're interested, you can find more information under this link. Very briefly, the sources that we would like to mention. Today, we published on the EMSA website this global map of minimum energy performance standards for electric motors. You find more detailed information when you hover with your mouse over each country. And we also have a summary table available for download. Did I mention in the beginning, today we also published on the EMSA website an overview of motor energy efficiency standards, not only for motors, but also for pumps, fans, and air compressors. We aim to offer an overview. For example, this table here shows which standard is applicable to what exactly. And we also have tables with more detailed information on each of the relevant standards. 2 publications are upcoming: the U4E Policy Guide and Model Regulation Guidelines for electric motor systems. The Policy Guide is a single-stop reference source for emerging markets and developing economies. So this is intended for policymakers in these economies. It is using the integrated policy approach, so differentiated for new equipment and installed base. And it offers an overview of resources, tools, and best practices globally. The model regulation guidelines provide a template on how to make MEPS, regulations for motors, variable speed drives, fans, pumps, and compressors. And they serve as building blocks, meaning each country, each region has its individual characteristics. So these templates serve as a guideline for them to adopt to their own needs. The publications are coming soon. They are not yet available. However, a first version from some years ago is available. The update will be there soon. Last but not least, we also would like to pinpoint to other sources. For example, CLASP offers an appliance and equipment policy tracker. This includes other policies, not just MEPS, and also other types of equipment, not only motors and motor systems. Now we jump to the conclusions, and we are running a bit out of time, but I hope you can still hang on for some discussion. So we see at the present that standards serve as building blocks for regulations. The standards for motor systems are being coordinated and aligned under JAC 22, mentioned by Maarten. As the motor system itself is complex, the standards need to align with that too. MEPS for motors evolve and expand in scope, stringency, and coverage worldwide. However, they are getting close to reaching their maximum. MEPS for pumps, fans, and air compressors are in place in a few regions only and are evolving from a component to the whole unit level. In future, we think the most important issue is how to harvest the system savings. In terms of MEPS, what are the metrics? Next to metrics for efficiency, we can also look at metrics for reducing power. Maarten mentioned the NEMA power index, which goes into this direction. We talk about enlarging the system boundary and about weighing benefits and burdens. Maarten mentioned, for example, with the case of variable speed drives, if certain measures are being applied, this bears cost, but also benefits in terms of savings, and for the regulator, additional effort. Other types of regulations other than MEPS are important for addressing not only new equipment, but also the installed base, and effective supporting policies are needed to complement efforts in MEPS. Let's keep in touch. We have a newsletter and we are on LinkedIn. So please, if you don't receive our news yet, sign up or join LinkedIn. And we are ready for your questions. Thank you for your attention.